Static analysis of a solid beam subjected to pressure load. In this tutorial, we are going to see how to do static analysis using brick element. Along with that, different post-processing capabilities of Previn will also be demonstrated. The beam is having a height of 500 mm with a rectangular cross-section of 100 mm by 100 mm. The beam is fixed at the bottom and a pressure load of 100 Newton per mm square is applied at the top end. Now let us first create quad surface using 4 corner points. First point is created using coordinate data 0, 0, 0. Second point is created using coordinate data 100, 0, 0. Third point is 100, 100, 0. And fourth as 0, 100, 0. Show the entity label by checking points. Next, create the quad surface on XY plane. From Geometry, Surface, Create Quad Surface menu. Specify the corner points by picking the points from the display area in the order of 1, 2, 3 and 4. The quad surface is created with the selected points. Now mesh the quad surface using Mesh, FE Mesh, Quad menu. Pick the surface from the display area and set the initial size as 10. Now adjust the seed points by 10 by 10 by clicking right and left mouse button on the appropriate edges. Select method as mapped in the parameter box and click apply to generate mapped mesh on the underlying quad surface. Erase the quad surface using surface erase and picking the surface ID on the parameter box. Now convert the 2D mesh to a 3D frame using Mesh, Element, Create, Extrude menu. Specify the element IDs as all, extrude vector as 0, 0, 500 and number of segments as 50 on the parameter box. Click Apply to create the 3D mesh. Display the model to fit to window and make it left view from the View option button. Next, specify the displacement boundary condition on the bottom face nodes through Load BC, Displacement BC, Add menu. Pick the bottom face nodes from the display using Isoface option and specify the BC value from the BC dialog. Arrest UX, UY and UZ degrees of freedom. Now display the BC in the display area by selecting the left view button. Next, specify the pressure load on the top face through Load BC, Pressure, Add menu. Use Isoface to pick the nodes and specify pressure value as 100 in normal direction. Specify the material property using Property, Material, Isotropic, Add menu. Select element IDs as all and material data from the material data dialog. Set modulus of elasticity as 200 GPa and Poisson's ratio as 0.3. Next, set the analysis type as static and click Apply. Set the analysis option Linear Solver as multifrontal. Set analysis static, general, add and select stress output as S and click Apply. Now select File, Save and choose appropriate directory to save the file with a proper file name. Now click Run Solver to execute the model using Fees Solver. The results and output files are generated. Now Pose, Deform Shape, Apply will show the deformation of the model. Check Superimpose option to superimpose the model on deformed shape. Now animate the deformation by checking the Animate Deflection and stop post-processing by clicking Stop button. Select Post, Contour, Displacement as item and click Apply to view the displacement contour. Change the item to stress and component to von Mises to view the stress contour. Highlight the maximum stress by checking the Highlight Maximum. Principal stress can also be selected from the component option. Now enable the multi-port view by clicking the multi-port button with 4 ports. First port displays the stress contour. Second, third and fourth port can be manipulated independently by rotating, panning, etc. Different results like von Mises stress, principal stress, displacement, animation, etc. can be independently shown in each port. Viewports can be set to single port by selecting single port button. Display the section contour to pose, section contour and selecting item as stress, component as von Mises, plane as normal to z-axis. Pick the section plane and animate the section. The section contour will be animated back and forth showing stress values on that plane. Vector plots can also be shown by selecting items as reaction force.